We are back live. Hi. Here's the plan. I'm gonna be here all day, minus breakfast in an hour. Um, we want to get pretty dang close to the release today. I think we can start running almost some of the final experiments. Pretty close to final experiments. And generally looking at the remaining items that need to be done before release. The fact that Neural MMO is just not learning stuff is a little weird. How about this? I mean, this is a really good one, right? I mean, our sweep code definitely works. I think Neural MMO is just hard. Take a quick look at the to-dos. I mean, to be fair, there are like a lot of small things we can just like start doing one by one. Minor M should work on one hyperparam set. Why don't we see if we can get... Could we do like breakout and then like triple triad or one of those? Those would be like two pretty different M's, right? Or do we want to see if we can get mini batch size actually sweepable? That might be better. Let's just start doing like a few things on this. Playing around with this. Breakout trains. Breakout here. And I have some like custom coefficients on here, it looks like. See, that pushes it over 3 mil like immediately. Oh, it's just gonna keep getting faster, huh? Okay, let's fix the speed reporting so I can actually see what's going on. If we ship like 5 mil SPS train demo, that would be pretty cool. I don't even know if that's feasible, we'll see. What did I do that would have messed this up? I guess like the fact that this is time-based. Want to append? No. We want to do like still no. Okay, whatever. We'll leave it like this for now. We'll see if we can come up with something better after, but this is decent. So how does BPT Horizon work now in the latest version? Batch size over total agents. That's not bad. So apparently we can just do this. This like VRAM at 20 is actually kind of correct. What changed that I am allowed to do this? Can I just keep making this larger? Can I just do batch gradient descent on this? Like, does this actually just work? Well, that's weird. 4.3. Okay, but you kind of saturate the gains like before then, right? Is this actually like train? Not really, right? But then if I do... I mean, what would this be? Just like way bigger learning rate? Yeah. I mean, it's cool to see, though, that we can actually, like... We can actually play with this variable now. I don't actually know what changed. Before, you know, in the earlier code, when I would do this, you would get a diminishing returns after, like, it would go negative after some point. I guess, why don't we try to, like... Why don't we see if we can, like, max perf on neural MMO then, right? So this box that I'm using here is sitting on the shelf behind me. Right? You can see it right there above my thumb. This is a pretty nice config. I wish I'd gotten more of these, but they're on tariffs now. Okay. Okay, so this was just not sweeping mini batch size. Very nice. You could say I've been doing some refactoring on this. And then we go here. Okay. Interesting. Oh, I just have to rebuild this. I did modify a bunch of CUDA. Okay. Let's just let's have a little bit of fun until breakfast and figure out what is the like ludicrously fastest we can get stuff to train with Puffer now. Okay, so out of the box, we're close to 3 mil steps per second with default settings. I do this. Holy hell. Over 5 mil SPS training. Now, it doesn't learn anything with these settings, and I have no idea if it's even possible to learn anything with settings that look like that. Hang on, so what does that imply? Does that imply, like, way more environments would be better? Because, like, the way that this works, right? It's mini batch divide by total agents. So the way, like, I generally set this up, it's 524,288 divide by 8192 agents is 64 horizon. So then, like, 131,072 divide by 64. It's actually only a 2048 batched forward pass, I guess. Let's see if I can get the env to bottleneck it by messing with these settings a little bit. So, like, let's go to, like, some ridiculous batch size. Wait, what do I need to multiply this by? I think just, this will satisfy it. 2090. Yeah, this one. Okay, and now I have to multiply this by 16. Something like this. Six million steps per second. If I go one more. It gets slower. Oh, because hang on, that's because the BPT horizon though. Did I mess up something? The forward pass got faster. Do 8 workers. Actually, it's a 16. Like this. M's must be divisible. So we get hit by like massive copy overhead, huh? I mean, there are two things that are a little weird here, right? One is that the env is way faster than this. The env should be running at like tens of millions per second. It shouldn't be this, like, really any amount of the compute. And the second is the copy overhead shouldn't be that high either. Like, if we just look up, like, okay, this is literally like almost 2 terabytes. So then why is this, are these, like, is this like copy overhead or something? Like, what is this? Let's go look at some things here. First of all, let's like try to get this into a state where we expect this to do something more reasonable. So 9%, massive number of M's here. I was going for 32. Can you check out my sweep? Yes, Spencer. I am I'm trying to see if we can hit like some ludicrous speed run on Breakout, but yeah, I can totally check out sweeps. Just link them in the Discord. Oops. Oops, not that. I think I should kill the run and switch. Let me look. Getting collision below 1%. Is this with immunity? Okay, so this Pareto run is not like you're getting all the perf very quickly. Here. We'll do a little live analysis. It'll be good for you and for folks watching so you can see how I look at these things. Okay, so this is capped out. This ended up actually being a pretty good length here. Is this... Wait, is this 100 mil? This is 100 million steps at the high end, right? Oh, 150 mil. Okay. I mean, but you're getting capped out perf in literally, like, no steps at all here. So I mean, that suggests that it's not just, like, I don't know why annealing would help you then, because you still have plenty learning right here. You have a few unstable runs, which is interesting. It improves slowly, does it? That looks flat to me at the top. So this is on log scale and it's still flat at the top. You see? Unless there's some in here that are like But the best ones seem capped. Interesting. Let's see what you did on sweep. You have your own. The one annoying thing here is just these plots are not going to be fun for, because these are like percentages. It's really tough to do analysis on scores that have like percentages like this. You can't really do a ton about that. It's kind of a Neptune problem, but like you have to kind of like, what difference actually matters when you get up here. I mean, these are actually, these are still not to 99, so you can still kind of look at the relative differences here. 95. Yeah. Well, this seems pretty good, right? There's like a little bit of a curve to this with the vehicle collision. So this seems to have an effect. Maybe a small one, right? Like this looks like a pretty consistent line here. This off-road collision, if there is an effect, it's less. Because, yeah, we've got 0.95 and 0.948. So this doesn't seem like it actually matters anywhere near as much as, like, over here, 0.95, 0.93, 0.93. Yeah, so there's, like, this does something. Completion rate is not... Is completion rate not score? The point of having the score variable, or I guess the perf variable now, either of those is that it should be the metric that you care about when you plot stuff, so that regardless of what experiments you're running, you can apply those plots and you'll actually get the plots you care about. Well, did any of these have completion rate plotted or no? Yes? In here or where? It's in there. Okay. I mean, I see one plot with it. If this is the metric that you care about, then this should be the y-axis for everything. Right? Score is more important than completion. Okay, well then if this is the metric we care about, let's see if I see anything. These are some ridiculous learning rates. I see. Well, fine. High value function coefficients consistent with what I've seen. I'm arguing over like 3% here. Well, but like you're not arguing over 3%. Like 3 percentage points from 51 to 54 is very different from 3 percentage points from like 97 to 100, right? Like if you look at relative improvement or relative error reduction, Like 99.9 is 10 times better than 99. Your games with time. Why do you think that you should get... Wait, why do you think it should be better without annealing? I have had runs that had episode return greater than 8. Have you had runs like on this version that have done that? This seems hard bound at 8. Like, what does 8 signify? Is there like a significance to the number 8? It just happens to be... Oh man, that there looks like there's a significance to the number 8 when I'm seeing 7.991 and nothing is above 8. Oh, I guess there's an 8.0027 here. Okay, so it's not impossible to get above 8. But that's like suspiciously close to a whole number boundary. For that like to signify something, you know? %5 vehicle collision. Okay, we can look at collision. Okay, I mean, here's like... It kind of levels off, though. Completion is basically 100, and off-road is 0.3. But, like, this collision stuff could still be from things... I guess it can't be from respawning anymore, right? Because that's no longer a thing. Clean collision is the better one. I mean, but these are, like, flat. Right? Here, let me stop making you type stuff. If you're not in, if this is easier.
Yo.
Hey.
All right. So basically, my assumption, and this can be wrong, is that if you have like a small enough learning rate towards that, of which I've seen in the experiments on the annealing ones, like it's still making like tiny improvements on one of the configs on one of like the parameter sets I had yesterday. But then it just dies because I only set it to like 100 million steps, right? So I
Yeah, so
figured if
why
I
don't you go
found,
longer with annealing on?
well, I could. I mean, then it's just a matter of like, do I just set like a fixed point further down the road, like set like a fixed like 300 million in resweep? That would,
Oh, I see what
or
you mean. Yeah, you would just set a longer max, and it would have to figure out the annealing coefficient.
Because I mean, at this point now, there's like a ton of
Right.
parameters, right? So it's hard for me to kind of gauge like if it's actually
Well,
fully
I mean,
explored
it's
tail end.
I our sweep stuff is pretty damn good at this point, I will say. Like, it's not perfect, but the sweep algorithm is pretty damn good at finding hypers. And you do understand how annealing works, right? Like,
I mean, it just slowly reduces the learning rate.
but do you like understand how much of a difference that makes? Like, where's this? Trapezoidal LR. Is it? Okay, so like, so this is cosine annealing, okay?
Yeah.
And then this is like this trapezoidal thing, which is like this other one that they introduced. So the point is that it has like this cooldown here.
Hmm.
Okay, look at what a difference this makes in the graphs. So this is the annealed portion right here in the loss.
Okay.
So like your curves are going to be smooth with cosine, so you can't really appreciate how much the annealing is doing. But like literally just like pulling down the learning rate at the end, this is how much better you do versus having one fixed learning rate.
And this graph is the y-axis going lower, good or bad?
Good.
Okay.
So this is like language model stuff. I guess the thing is you weren't around when like let's see. You probably weren't around to like see the early like reduce learning rate on plateau or whatever graphs. But basically, we used to have graphs in ML that would look like this, and they would like be like sawtooth or whatever because you would reduce the learning rate like several times throughout training.
Hmm.
So like reducing the
Just like
learning rate
step
makes it
function
learn
lower.
way faster in certain cases. So like you don't see it because cosine is a smooth schedule. And so is like linear, but like yeah, I don't think just disabling like you could just break stuff basically by turning annealing off. It's worth trying once in a while because like yeah,
Hmm.
sometimes M's just they work like that, whatever. But often it's like yeah, you want to keep annealing and then just have it be able to run for longer. And that's like one of the things we discovered with Breakout, right? Like like without annealing, we totally broke it.
Yeah, I mean that was something for breakout. But like for neural MMO, don't you do a linear learning rate for like 2 billion steps?
Well, why do I do that though, right? I do that because the full run is 100 bill. So like me annealing over 2 billion, I do it so that if I okay, I guess here's the one thing I do. If I'm going to do like a sweep run, and then I'm going to do like a 50x longer run afterwards, then yeah, you can disable annealing because it's a better chance that the hyperparameters will transfer. Is that what you were going for?
I mean, I assume that when you're going from a linear learning, not I mean, just a fixed learning rate versus using some form of annealing, that you have to have entirely different parameter sets.
Um, Possibly. The main thing is like, usually you do it on. There are a few variables you usually do it on, Jason, but yes. So like, the reason I do it, and I think we're getting at the same thing here. I can't quite tell. So like, let's say that you're gonna run some experiments, and you just want the best performance, right? And higher is
Sure.
better. So like,
Yeah.
and then you anneal, right? Then you'll get something that's like this, right? You get your curves or whatever, and
Sure.
then, but the thing is like, if you keep running these are already at like 0 learning rate here,
Hmm.
right? So like, you can just set them longer, and you can like hope that you do this or whatever, but
Hmm.
like it's not really guaranteed because the annealing is kind of a different factor, right? Which actually, to be fair, this is actually the reason that this thing exists. Because you can just keep extending it, and then just at the end is when it cools down. Um,
Mm.
but the annoying thing about this is that you have to wait all the way for the end of training to see if your experiment's any good, right?
Isn't there something to say about annealing? If like, so say right now, like, right, like it's basically getting to like its peak performance within like effectively, anywhere from 50 to 70 million steps right now,
Hmm.
right? Um, is there not an argument that like the time of which it is at a certain learning rate, it could learn better if it was exposed to that learning rate for an extended period of time versus continuously dropping through
This
that
is
point
so
in
this is
time.
that, right? So this is a constant learning rate. So this is a warm up, which we're not doing warm ups at the moment, so ignore that. This is constant learning rate, and then it drops it at the end. And this is the difference, right? Like this is how the curves tend to look when you do this.
Okay.
So like cosine actually it does better when you tune and anneal the learning rate typically. But then when you do the cooldown at the end, you actually match. Like the graphs pretty well match.
So pretty much the same thing at the
Yeah.
end of the day.
So
Okay.
basically, like it doesn't seem like there's really a huge amount of magic in here. Like that
Hmm.
these two totally different methods do the same. It's just like experimental um convenience with like, do you want to be able to have the same learning rate so you can just run it for way longer and see if it just keeps going, but then you have to wait for the very end versus with cosine you probably have to retune a little more, but at least you get the experiment results like as they happen. You get the cleaner curves.
So given the current setup, is there not an argument for saying that okay, so right now I think my cap is 200, but I think it never even tried that. I think it
Hmm.
stopped at like 150 as the high for whatever reason.
Well, it stops
And
when it
it
can't
probably
make progress.
right.
It has to have
Is
a
that like
Pareto optimal
guaranteed?
point.
Right, is that like a guaranteed assumption though? Because like, could you not
Mhm.
have a set of parameters at like the 500 million step range that are
So
not just dramatically superior?
if it can't do any better with 150 versus like 100, there's not going to be a Pareto optimal point at 150. So it'll just keep sampling around 100. The way it does it, it only expands to longer runs when it finds a run that does better than a previous shorter run.
Okay, sure. Following that logic, that depends on the luck of the parameters chosen on the longer run, right? Like
Hmm.
if you happen to not find a good one, you're going to be stuck in like a shorter time step land
Well, not
until
entirely until you find
it
it. Like,
suggests a better one, right?
but like what it does, right? Like, let's say that you run some experiments, and this is like time, and this is like score.
Sure, sure.
Then like you tend to get like stuff that looks like this, right? And let's
Yeah.
say that this is your best point. Then what it does is it looks for it's going to look like between roughly like here and here as the max
Mhm.
around this point. I mean, technically, what it like it can do is the way that the algorithm actually works is it picks a time interval from like here to here, and then it's going to pick a point. It's going to try to pick a point that it thinks is going to take this much time. So like it could pick one here, and then it's going to get a whole bunch of candidate points, and it'll pick whatever it thinks is the best point. So like it's going to try to put points over here some fraction of the time. But if it can't do better than this point, it's not going to waste the compute. But like
Okay.
it's generating a ton of different candidates and using predictive models to score like what it thinks the best point is over here.
All right. So going back to my setup of the latest run,
Mm-hmm.
would the proper analysis be of it, okay, it's just capped performance and it's now down to like bug in data set or some type of like map related issue?
Well, I mean, I can't say for sure. There are many things it could be. Some things that you could do to test it, right? You could take the best set of parameters, just increase the model size, maybe fiddle with the learning rate a little bit and see if you get anything that like breaks past. It seems hard stuck at 8, which is suspicious to me. It would seem like there's some significance to the value of 8. Um, let's see. You can definitely run. Well, yeah, longer sweep is it's not finding anything, right? So it's just like not.
And I'm only suspicious because I have the current set of params that are in the release
Hmm.
branch that I have, which honestly I think may even be I don't remember if one of your sets or a set I found on a different suite, but anyways, um, one run on a short round of like 80 million, everything else stays the same, gets, still 99 completion rate, like basically 0 off-road rate, and then anywhere in the range of like 4% vehicle collision. When I pump it to like 150 million on the same steps, it seemed as if it went down to like 3.3, giving me hope that like there does exist some form of parameters that could get it down to like 1 or below 1
Well,
if you just either continue extending it some way somehow.
collision rate or clean collision rate?
Clean collision rate.
So on this
But the
version,
sweep did not discover it. Like the sweep did not discover something that aligned with that particular run I just did on my computer.
what is this one right here? Neptune's really got to make it. Oh, here, yes, it did. 0.27.
Right, but
0.027.
it also sacrificed other parameters to get there on that run. So if you find that run and you click into, I don't remember. Let me see if I can just find the number of that run.
2059. %95 score.
Yeah. And then if you go to off-road rate, you'll see this is actually higher than the majority of the other ones. Where is
0036.
Hold up. Is it off-road rate? No, something was funky with this one. Is it completion rate?
97.8.
Yeah. It has not gone to 99 like the other ones.
Well, what are the coefficients on the rewards, I wonder? It's probably just down to that.
Yeah, that'd be under N.
I mean, it's playing scared. It's probably playing scared, right?
Sure. And like that's the only one that was able to get basically sub 3 collision rate.
And the collision rate, that's not including the... It's not just because the spawn immunity timer is really high, right? It's like...
Yeah, so there's two things. Clean collision rate will always be first life. So irrelevant of the timer. The collision rate basically equals clean collision rate at a very high spawn immunity timer. The lower spawn immunity timer is, collision rate diverges from clean collision rate to be higher because of the situation where you spawn into other cars. So like
Yeah, I
this
mean, this
leads
thing
me to
just...
really
It must just be playing scared, right?
Mhm.
Which is like...
Now, for the purposes of like moving forward, at what point do we say that these quote 72 maps are solved? Because it's possible one of these maps is just so out of distribution from the other maps that it's difficult for it to solve relative to its learning. If you were to do 100 maps or 10,000 maps or whatever.
Well, I would think it's definitely worth getting more maps in because we're gonna want to do that anyways, and it'll be better for experiments. Like just the padding thing that I would suggest, right? That I suggested, would let you load random maps per worker, which would already give you a bunch.
Okay, so let's talk through that one because conceptually I had a hard time trying to think about implementing it. Um, you're going off picking number of agents, which let's just assume 4096, right? If you have 4096 agents and you want to make it pretty dynamic on your map choice, whether you're choosing one map or 4096 maps,
You just randomly select maps until you get close to that.
so you randomly select maps as within your init and resampling, right? Because you have to recalculate your agent offsets within that thing. Because
Well, if you resample, so that's the thing where they switch the maps every so often, and it's kind of slow.
okay,
We're gonna do that, but I wouldn't even say bother doing it just yet. just like initially, can we at least get each worker to have independent maps? Because we have 16 workers or 8 workers, whatever it is, and like they're all on the same maps right now. Right?
Yeah, okay, so you're saying each worker to have, because each worker picks a random set,
Yep.
so that them to have different ones. Um, okay, let's talk about padding then.
It's
You
not
get to the
padding.
point where,
It should be the opposite. It would be so you pick
like,
maps
cutoff
until you pick,
over, right?
yeah, you go over, and then you just drop the last few cars, whatever, so that you have exactly 4096 in the obs.
But that's not anything to do with the actual .h file, right? Because you're just cutting off the edge of it and you're just saying, okay, this is now the end of the offset,
Mm-hmm.
and it's just going to,
Yep.
I guess that's a little awkward, but it
It's a tiny
would,
bit awkward, but not really, right?
I guess some cars are going to get no actions.
Yeah, some cars are
Is
just
that,
going to park in the middle of the road, or you could
or I
remove
guess,
them, which would be better.
okay. So there will be, I guess, possibly a little bit of logic. How is that going to get passed in? Uh, I guess from actions, right? I could go based off the shape of actions and then cut off anything past.
Well, you don't have shapes in the C. It would be
Well, you can have the length though, because you're gonna be given an array of actions.
the C is just a pointer. You still have the number. You
Mm,
still know the number of cars and stuff total, right?
there's no reason why you wouldn't know
Hmm.
the total number of cars.
Remember, you also can pass stuff to the init function of binding. So like, you can just
Yeah,
pass num. You
yeah.
can pass num
I mean,
cars, right? And just like
you
on
could
the
pass
last one,
in.
you can just like cut the max lower. I mean, technically, there's no reason you can't load. You can load any of these maps with any number of the cars from like 0 to however many they actually have, right?
Mm, there's a little bit of funkiness in that, but should generally be doable because if you're lowering it from inside of one of the init functions
Mm-hmm.
after the fact,
Doesn't have to be after the fact.
I think I'd rather find a way to do it inside of step somehow. Um, like maybe
If you don't get an action for a
like
car, it just
overriding,
blinks out.
like, like if you override the active agent count variable via the binding.
Mm-hmm. I mean, whatever way makes sense with it, but like, you have the unbinding now, and you have debugging that runs through Python. So
Okay, but in the condition of less maps than total agent count,
mhm.
or I guess in this case that's our num_ems variable, just modulo it,
Yeah, or max or whatever it is. Yeah.
or whatever the right mathematical
Mm-hmm.
operation is to get a unique number that fits in the that's divisible or whatever.
Yep.
And no resampling, so each round will continuously just replay the level it's given on that set of levels at the moment. Like when it dies,
Initially.
it's not gonna pick a different random map. It's gonna
Yeah,
stay
initially.
in the set of random that it's been given.
Yeah, initially. And then the way that they did is just every so often they resample everything.
Which I don't think should be that bad. I mean, the initialization isn't too slow, but I
Mm-hmm.
mean,
Yeah.
if you do it for that many maps, maybe it's a little slow.
So I mean, we'll see with this, right?
Okay, so for max parallelization, should I start with doing like the 4096 Or should I just do like 1,000 or 100 or some just a number that works?
Just whatever is close to the number of cards you have at the moment. I think it's like 512 per worker.
Oh, okay. Just get okay. I see what
Yeah.
you mean.
You're literally all
Okay.
you're doing is just trying to make it round off to something clean so we can actually like do stuff with it.
Okay. I will get to work on that.
Cool. Thank you. And
Yep.
I will be after breakfast back here for the whole rest of the day. So,
Yep.
all right. Thanks, Spencer. Cool. So I've got to go for breakfast in a few here. So to folks on Twitch and YouTube, I will be back after. I'm going to do a couple last things on this, but I will have to go in a minute. So after breakfast, I will be back for the whole rest of the day working on probably seeing if we can get some really high perf demos here, clean up a whole bunch of stuff in PufferLib, really just get all this stuff ready for release. All my stuff is on puffer.ai. It's all free and open source code. If you want to support this work for free, just start the GitHub. If you want to get involved with development, you can join us on Discord. You can also follow me on X for more RL content. But we will stay here for another couple of minutes just to see. Hey, Boxen. Are you going for breakfast? Yeah, I'm going for breakfast in a minute, but then I'm back for the whole rest of the day after. Usually food breaks at 10 and 6. It's a massive copy overhead. Would you mind answering some questions? Of course. I'm going to have to go in a second, but yeah, after breakfast, of course. %45 copy overhead is ridiculous. How much of it is in here? Is it still 45% if I do this? Huh. 44. It is literally all just in right that function. It's probably literally all in right here, right? Yep. If I take this one line out, ridiculous. How much data is this? $60 megabytes. And that is for 131 So if we do like 8.1 million times 4. That is 3 gigabytes, 3.8 gigabytes per second. Which is nothing for a CUDA device. So why is it that long? These are like good sized blocks too, right? These are not tiny little transfers. Well, I think what we'll do is we'll check out. What we'll do is we'll look at like the difference between if the memory is pinned or not after breakfast, and then we will go from there. So yeah.